Good day everybody, we have been given this question, integral pi over 3 to pi over 2 positive 3 times sin x divided by sin x of 1 positive cos x. So foremost what I wish to do is I would like to rewrite this as integral pi over 3 to pi over 2 over sin x of 1 positive cos x positive 3 times sin x over sin x times 1 positive cos x. Now times dx, and this will also be integral pi over 3 to pi over 2 times the dx. Now this can be further rewritten as, I can take 2 out and multiply the numerator by 1 negative cos x and also the denominator by 1 negative cos x. So there is going to be sin x times 1 positive cos x times 1 negative cos x times the dx. The limit stays pi over 3 to pi over 2. We don't do anything for this, so it's going to be 3 times of. Now sin x can be cancelled, right? So just place the dx there divided by. Now 1 positive cos x. What we can do is, we know this formula, 1 positive cos 2x divided by 2 is cos squared x. Now we just have x there, so suppose you take 2x is equal to some u, then x is equal to u over 2. So this is going to be 1 positive cos u divided by 2 is equal to cos squared, in place of x you have u over 2. And rewriting this, 1 positive cos u is equal to 2 times cos squared u over 2. Of course we can refractor this to represent cos x. So this is going to be 1 positive cos x is equal to 2 times cos squared x over 2. So this is the substitution. So in place of 1 positive cos x, I am going to write it as 2 times cos squared x over 2. Okay. Now coming back to the first part, of course the limits is pi over 3 to pi over 2. Now this is going to be 2 times pi over 3 to pi over 2, 1 negative cos x divided by, now 1 positive cos x and 1 multiplied cos x, 1 positive cos x times 1 negative cos x, that would give me 1 negative cos squared x times sin x times the dx. Now let me just simplify this. I will just write this as plus 3 times some i3. Why am I writing it as i3? Because there will be 2 components involved in this itself. So that is the reason I am writing this as i3. Okay. So what I wish to do is I would actually split this in this following fashion. So 2 times of integral pi over 3 to pi over 2. One part is going to be dx over sin x times, now 1 negative sin squared x, or I would say 1 negative cos squared x. 1 negative cos squared x is sin squared x. So write sin squared x there times the dx, followed by integral cos x over sin x times sin squared x. So let me write that for sin x times sin squared x times the dx, positive 3 times i3. So let me have it as it is. Now of course the parenthesis has to be completed. So this is going to be 2 times of, now sin x into sin squared x, that is going to be sin cube x, right? So dx divided by sin cube x negative, this is going to be cos x over sin cube x times the dx, positive 3 times i3. Now let me take this first part of the integral as i1, second part of the integral as i2. So what we have to do, we will have to consider each of the integrals. So foremost what I would do is I will consider i1, get the value, or I would say evaluate, get the value, then consider i2, evaluate, get the value, then come over here, find out the value for 2 times i1 minus i2, and then find out the value for 3 times of i3, and then club everything together and write the final solution. So that is going to be our objective. So let's get started. Pi over 3 to pi over 2, this is equal to integral. Now 1 over sine cubed x, right? So I can rewrite this as cosecant cubed x dx, and this is pi over 3 to pi over 2. Okay, fair enough. Now what I would like to do is I would like to split this cosecant cubed x as cosecant x times cosecant squared x. Now this is going to be equal to integral pi over 3 to pi over 2 cosecant x multiplied with cosecant squared x dx. But there is a formula. What is the formula? Cosecant squared x negative cos squared x is equal to 1, and cosecant squared x is 1 positive cos squared x, and cosecant x is equal to square root of 1 positive cos squared x. So take this, substitute it here. Okay, I hope you are watching this. So this is equal to integral pi over 3 to pi over 2 square root of 1 positive cos squared x times cosecant squared x dx. Now let me take cot x is equal to some t. So what do you get upon differentiation of cot x? You get negative cosecant squared x dx is equal to dt. You don't have a negative sign, so this is cosecant squared x dx is equal to negative dt. So this is what you got. Now we have to set the limits. So x is equal to pi over 3. What happens to t? My t is cot x, right? So I will rewrite that as cos x over sin x, and x is equal to pi over 3. That's cos 60 by sin 60. So if you substitute, you get 1 over root 3. So this is the value for t when x is equal to pi over 3. Okay, so when x is equal to pi over 3, this is the value. Now next comes x is equal to pi over 2. When x is equal to pi over 2, t is equal to 0. So what are the limits? So let me go to the next page. So what I'm going to do is, so therefore, let me start from here. So we have, what do we have? Pi over 3 to pi over 2 root of 1 positive cos squared x times cosecant squared x dx. I have taken t to be as cot x, and dt, negative dt is cosecant squared x dx, right? So this is equal to integral 0 to, no, it's not 0. This pi over 3 produces us 1 over root 3. And the pi over 2 gave us 0. So this is root of 1 positive, t is equal to cot x t squared, negative dt. So cosecant squared x dx is negative dt. So I place the negative there and a dt there. Now I reverse the limits. From 1 over root 3 to 0, I'm going to place it from 0 to 1 over root 3. So this will become root of 1 positive t squared dt. Now we have to integrate this. So to integrate this, what I wish to do is I'm going to make the following assignment. Let t be equal to sin x. So this means x is equal to sin inverse of t. So that is just a deduction that we get outrightly. Now the next is we have to differentiate t, right? So differential of sin x will give us cos x. So 1 positive t squared is 1 positive sin squared x, which is nothing but cos squared x. So root of 1 positive t squared is root of 1 positive cos sin squared x, which is root of 1 positive cos squared x, which is equal to cos x. So the integral, if I were to take it as sum 3, this 3 can be rewritten as equal to, I'm not touching any of the limits here. So this is equal to cos x dt is cos x, and this is cos x dx, so dx should be there. So cos x into cos x, this is going to give us cos squared x dx, so we will have to integrate this. I am going to use this formula. Now cos squared x is equal to 1 positive cos 2x divided by 2. So utilize this formula here. This is going to be equal to 1 positive cos 2x divided by 2. We have to integrate this. This can be rewritten as 1 over 2 can be taken out. So the integral 1 positive cos 2x times dx. I can rewrite this as 1 over 2 integral dx positive integral cos 2x dx. Right. This is going to be 1 over 2. Integral of dx is x. Integral of cos 2x is sin 2x divided by 2. So this is what we have got. So this is x. Right. So from here I can utilize x to be as sin inverse of t. Okay, fair enough. But sin 2x, okay, sin 2x is nothing but 2 times sin x cos x. But cos x is root of 1 positive sin squared x. Okay. Now this is equal to 2 times sin x, root of sin x is equal to t. So you can substitute t squared there. Okay. And this is equal to 2 times t times the root of 1 positive t squared. This is what you've got. Right? Now, we have sin inverse of t there. Okay? So if I were to rewrite this, so this is going to be half times x is going to be sin inverse of t plus this quantity sin 2x. Sin 2x is this. So 2 times t root of 1 positive t squared divided by 2. Okay, so the 2 and the 2 can be cancelled, giving me 1 over 2 times sin inverse of t positive t times root of 1 positive t squared. I have to apply the limits, but still I don't want to apply the limits as yet, because I want to get the representation for sin inverse of t. How do I do that? Okay, now let me come back to the substitution. We know that t is equal to sin x, but sin x has got representation as e raised to the power of x negative e power negative x divided by 2. You cross multiply, you get 2 times t is equal to e raised to the power of x negative e raised to the power of negative x. This can be rewritten as e raised to the power of x negative 1 over e raised to the power of x is equal to 2 times t. I take the LCM as e raised to the power of x. This is divided by 1, so this is going to be e raised to the power of 2x negative 1 is equal to 2 times t. So you cross multiply, you get 2 times t e raised to the power of x is equal to e raised to the power of negative positive 2x negative 1. Bring everything to the right hand side. So this is, I hope you are watching, e raised to the power of 2x negative 1 negative 2 times e raised to the power of x is equal to 0. I can rewrite this as e raised to the power of 2x negative 2 times t e raised to the power of x negative 1 is equal to 0. I want to rewrite this as e raised to the power of x raised to the power of 2 negative 2 times t e raised to the power of x negative 1 is equal to 0. Now let me take e raised to the power of x to be equal to some p. So this is going to be p squared negative 2 times p negative 1 is equal to 0. I am using quadratic formula. So a is equal to 1, b is equal to negative 2t and c is equal to negative 1. So p value will be negative b plus or minus root of b squared negative 4 times a divided by 2 times a. So this is negative b is negative 2t plus or minus root of negative 2t the whole square negative 4 times a times c negative 1 divided by 2 times of a. So this is going to be positive 2t plus or minus root of 4 times t squared negative negative positive 4 divided by 2. I can take 4 out, it will become 2. So root of t squared positive 1, I want to write it as 1 positive t squared. I'm only taking the positive value. So positive 2 times t is equal to, or I would say divided by 2. Right. My 2 and a 2 and a 2 gets cancelled, giving me t positive square root of 1 positive t squared. So what is this? This is my p. But what is p? P is nothing but e raised to the power of x. So you can write e raised to the power of x is equal to t positive root of 1 positive t squared. Now what I'm going to do is I'm going to take ln on both sides. So this is ln e raised to the power of x is equal to ln of t positive root of 1 positive t squared. Right. Now there is a formula, ln a raised to the power of b is equal to b times ln a. So this is x times ln e to the base e is there is equal to ln of t positive root of 1 positive t squared. Ln e to the base e is 1, so x is equal to what? Ln of t positive root of 1 positive t squared. So in place of x, I will be substituting this value. So that's exactly what I'm going to do. So t ln of t positive root of 1 positive t squared. So this is what the solution is, right? Part of the solution, right? This is what the part of the solution, right? But what is sin inverse of t? Sin inverse of t is nothing but x, right? Sin inverse of t is nothing but x. So therefore, solution, this is equal to 1 over 2 times ln of, so what did we get? Ln of t positive root of 1 positive t squared, that's for the ln, positive t times the root of 1 positive t squared. So all of this are running from the limit 0 to 1 over 3, 1 over root 3. Okay, we have to place that limit 0 to 1 over root 3. So this is equal to 1 over 2 times ln of 1 over root 3 plus square root of 1 positive 1 over root 3 squared positive 1 over root 3 times 1 positive 1 over root 3 squared. So this is equal to 1 over 2 ln of 1 over root 3 plus root of, this is 1 over 3 plus 1 over root 3 root of 1 positive, this is 1 over 3. So this is equal to 1 over 2 times ln of 1 over root 3 plus 3 positive 1. So that's going to be root of 4 divided by root of 3 positive 1 over root 3. This is 3 positive 1. That's 4 divided by root 3. Okay. I hope you are watching. So this is equal to 1 over 2 times ln of, I take root of 3 as the LCM. 1 positive root of 4 is 2. So that's going to be 3 there. And 1 over root 3 times 2 over root 3. This is what you've got. Now I can write 3 as the root of 3 times the root of 3. So this is going to be 1 over 2 times ln of root of 3 times the root of 3 divided by root of 3 positive 2 over root of 3 times the root of 3. That's going to be 3. So root of 3 gets cancelled. You can bring this 1 over 2. So it's going to be 1 over 2 times the ln of root 3. 1 over 2 when it comes in, 2 goes off. It's going to be 1 over 3. So this is my I1 value. Okay. I hope you're watching this. So it is not yet finished yet. We have to do I2. So what is I2? I2 is this. I2 is cos x over sine cubed x. So now I'm going to consider I2, which is nothing but cos x over sine cubed x times dx. Now what I wish to do is, the limits are pi over 3 to pi over 2. So I'm going to rewrite this as pi over 3 to pi over 2 cos x over sin x multiplied with 1 over sine squared x dx. So this is going to be limits pi over 3 to pi over 2 cos x over sin x, that is cot x, 1 over sine squared x, that is cosecant squared x followed by dx. Now let me take, let t be equal to cot x. You differentiate t, you get dt. Differential of cot x is negative cosecant squared x dx. So this is equal to limits. Now if I were to substitute pi over 3 over here, then this would produce me cos 60, right? Cos 60 over sin 60 for pi over 3. And clearly cos 60 is 1 over 2 and sin 60 is root 3 over 2. So this limit is going to be 1 over root 3. And pi over 2 will give me 0. Now this is t here and negative dt. Okay? I can change the limits. So it's going to be integral 0 to 1 over root 3 t times dt. You square it, you get t squared over 2. The limits are 0 to 1 over root 3. You can take 1 over 2 out, substitute the upper limit for t squared, 1 over root 3 squared, followed by 0. So this will give you 1 over 2 times of 1 over 3, which is nothing but 1 over 6. Fair enough. This is my I2. Now go back to the question. What does the question says? Question says 2 times of I1 minus I2. So if I were to take it as sum 5, therefore 5 is equal to 2 times of I1 minus I2, which is equal to 2 times of, what is my I1? This is my I1. You see here? Half times ln root 3 minus positive 1 over 3. So half times ln root of 3 positive 1 over 3. This is my I1 followed by my I2, which is 1 over 6. All of them have got a pre-multiple of 2 there. So if 2 goes inside, 2 and 2 gets cancelled, you get ln root 3, positive 2 over 3 and positive 1 over 3, isn't it? I take 3 as the LCM for this. This will give me 2 minus 1. Of course, you don't have to do anything for this. This is just ln root 3. So this is equal to ln root of 3 plus 1 over 3. 2 negative 1 will give you 1 and 1 has to be, the denominator is 3 there. So let us consider our I3, which is 3 over 2, isn't it? So 3 over 2 is our I3. So 3 over 2 times dx over cos squared x over 2. Now actually, if you remember in the last case, we took we treated I3 like this, 3 times of I3. So obviously in this case we will just have 1 over 2 there, right? Because we took the system as 3 times I3. So I3 is going to be 1 over 2 times integral dx over cos squared x over 2. Okay, so with this the limits are pi over 3 to pi over 2. So this is going to be 1 over 2 integral. Now 1 over cos x is secant x, 1 over cos squared x is secant squared x. So this is going to be secant squared x over 2 dx. Now what I wish to do is I will have to integrate this. Now if you integrate it, let me place the limits, pi over 3 to pi over 2. If you integrate secant squared x, you get tan x. Right. Now there is a coefficient there, the coefficient of 1 over 2 there. So what we have to do, we have to ensure that that 1 over 2 is taken care of. Now to avoid confusion, what I would suggest is, if you want, you can take say let x over 2 be equal to some u. So this means dx over 2 is equal to du. So this means dx becomes equal to du with the product of 2 there. So 1 over 2 times integral, I'm not touching the limits, secant squared x over 2 becomes equal to u, and dx becomes equal to 2 times of du. So 2 gets cancelled, giving you half times integral of secant squared u du, which is nothing but tan u, of course with the half there. Now you can replace in fact the 2 over here, and this 2 over here can be cancelled, right? So there won't be any 2 here. So this is just going to be tan u is x over 2. Okay, this is what you will get. Now if you don't want to do all this, what you can do is, integral of secant squared x over 2 is tan x over 2. You have to divide by the coefficient of x, which is 1 over 2. So that's going to be 1 over 2 there. The limits are pi over 3 to pi over 2. So either you can follow this path or directly you can integrate and place the value. So 2 gets cancelled. So what you are left with? You are left with tan x over 2, pi over 3 to pi over 2. Now you substitute upper limit, you get tan pi over 4. You substitute the lower limit, you get tan pi over 6. Upper limit will give you 1. Lower limit is going to be 1 over root 3. Okay, because it is 30. So sin 30 by cos 30. So this is what you have got. Now this is my I3. So therefore 3 times of I3 is going to be 3 times of 1 negative 1 over root 3, which is going to be 3 negative 3 over root 3, which is going to be 3 negative root 3, or I would say 3 can be written as root 3 times root 3 divided by root 3. Root 3 gets cancelled, giving you 3 negative root 3. Now this is my 3 times of I3. Okay, so now we have to go back to the system and make the final substitution. So I'm going to take this as some 6. So therefore 6 can be rewritten. What is 6? 6 is nothing but 2 times of I1 minus I2 plus 3 times of I3. Now 2 times of I1 minus I2, we just found that out to be as ln root of 3 positive 1 over 3. Now that added up with our 3 times of I3. What is 3 times of I3? 3 negative root 3. So it's going to be 3 negative root 3. So what we have to do is we can simplify the entire component. So if we have to simplify the entire component, this is going to give us, we can take the LCM for this. 1 over 3 added with 3. I take 3 3's are 9, which is going to be 10 over 3. So clubbing these two together would give me 10 over 3, and then you have a negative root 3 there, followed by ln of root 3. So this is the final answer to the question. Thank you everybody. Please like, share and subscribe.